Hello! In Module 2.3, we will learn about postulates and diagrams. In Lesson 1, we'll begin by identifying some postulates. Hey look, here's a postulate. It's called the two-point postulate. Through any 2 points, like these two, there exists exactly one line. So, to state this specifically, through points A and B, there is exactly one line, L. So that's your postulate. Kind of makes sense. How about the line-point postulate? A line contains at least 2 points. So on this line, we have at least 2 points. It's not very deep, is it? But it's important. Postulates and axioms, which we'll talk about later, are really the groundwork for geometry. 2.3, the line intersection postulate. If 2 lines intersect, then their intersection is exactly in 1 point. So in this case, the intersection of line M and line N is the point C. Alright, the 3-point postulate. Through any 3 non-collinear points, there exists exactly one plane. So through points D, E, and F, which are clearly non-collinear, right? F doesn't go on that line. So for these 3 non-collinear points, there's exactly one plane that contains them. It's called R right now. The plane-point postulate. A plane contains at least 3 non-collinear points. So if you have a plane, you know that there's on that plane, or actually in that plane, there are at least 3 non-collinear points. The plane-line postulate. If 2 points lie in a plane, like D and E, then the line containing those 2 points also lies in the plane. So, if points D and E lie in plane R, then line DE also lies in the same plane, plane R. That's a pirate's favorite plane, by the way. Arr! And finally, postulate 2.7, the plane intersection postulate. If 2 planes intersect, then their intersection is a line. So, looks like this. The intersection of plane S and plane T is line L. So it's kind of important to keep in mind that plane S goes forever in all of these directions. So line L, the intersection of these 2 planes, goes forever, because plane T also goes forever in these directions. But the most important directions are here, so that line L can go on forever in both of those directions. Alright, let's look at some examples. State the postulate illustrated by the diagram. If this, then that. So if 2 lines intersect, then it looks like there's just 1 point right there where they intersect. So that's the line intersection postulate. If 2 lines intersect, then their intersection is exactly 1 point. If 2 planes intersect, then the intersection is a line. That's the plane intersection postulate. If 2 planes intersect, then their intersection is a line. Yay! Ooh, this one looks intense. Use this diagram to write examples of the plane-point postulate and the plane-line postulate. Alright, the plane-point postulate says that if there is a plane, then that plane has at least 3 non-collinear points in it. So if let's look at plane Q. Let's see, point B is on plane C. Sorry, this is plane P. So if it's on plane P, then B can't be on plane Q. What points do we have in plane Q? I think just A. Right? A is the only one that we have labeled over here on plane Q. So let's look at plane P. On plane P, we've got B and A and line N and point C. So it's pretty clear to see that point C is not on line BA, which means that B, A, and C are three non-collinear points. And the plane point postulate says plane P contains at least three non-collinear points, A, B, and C. So that's a specific example of the plane point postulate. We got a plane, it has to contain at least three non-collinear points, and we have them right here, A, B, and C. We didn't have them on plane Q, so we couldn't say it about plane Q. Because what letters would we say? We don't have any points labeled on plane Q. There are more than 3 points. There's 3 or more points, right? We just don't have any of them labeled on plane Q. So the only statement we can say using the plane point postulate is about plane P. So what about the plane line postulate? So the plane line postulate says that if 2 points are in a plane, then the line that contains those 2 points is also in the plane. So since A and B are both in plane P, then line AB, or N, line N, is also contained in plane P. So points A and B both lie in plane P, so line N, which contains those points, also lies in plane P. Alright, so what did we learn? We were introduced to a bunch of super cool postulates about lines and planes, and then we practiced identifying them. These are they. So that should be in your notes, because notes are good to use on quizzes and tests and stuff. Well, have fun. Talk to you later.